Hello, my name is Austin Buffone, and I am currently with the 2023 Senior Design Group ME25, working with SKF on the precision measurement of frictional torque in bearings. This project was completed with myself, Austin Buffone, David Lasch, Joei Ritmiller, and Mark Schmidt. For the project overview, this is just a SolidWorks model of everything that we have created for this project. So we focus mainly on designing the vise, the heaters, and everything that was inside that shield, but we also had to look at the different outside tools that we were going to have in this, which includes stuff like the motor control, the gearbox, the pump, and the load cell. So for the objectives for this project, we had to adhere to the given specifications that SKF had created for us for this project to actually give a list of like wants and needs that we had to reach with this project. So for the examples, we have the temperature, because we had to hold this at different temperature ratings. We have the measurement accuracy and precision, because we were given a list of the amount of frictional torque we wanted to measure in the bearings and to which that accuracy was going to be. We had the variable loading in the bearing, and then we also had the oil flow to the bearing. And then the etc. is for other different specifications that we were given, but they weren't as important as these top four that I've listed already. The approach was we had to lay the groundwork for this project, and the groundwork included things like the objective tree, the functional model, and the list of specifications that we created based off of what SKF was asking for us for this project. Leading after that, we had the concept generation, which was all of us putting our minds together for a load of different designs to try and actually converge on a group design that would actually end up being the vise, which is the final design that we agreed on. And then the supporting mechanisms, which I listed in the first slide, which are things like the motor control, gearbox, the load cell, the heaters, things like that. And then lastly, we had to go into the hand calculations and compare those to ANSYS to ensure that this project that we designed works in the way that we want it to and is going to be accurate to everything that we designed it to be. So since we just talked about the ANSYS, there in the top right, you can see that is actually the ANSYS calculation on the smallest size bearing. The reason we chose that is because that's going to have the most forces and the most bending on the different parts that are going to be acting on the bearing. And then right in the center, we have the abstract for this project, as well as the test rig overview that was shown on the first slide. On the left side, we have both the background, the load application, and then after that is the frictional torque measurement, which was one of the most important parts of this project, which we spent a lot of time figuring out and doing all of the research into ensuring that this would measure everything that SKF wanted. We also had the component selection beneath that, which is the different components that went into this project. We have the capabilities right to the right of that, which is actually a broken down list of specifications that were required for this project. And then in the bottom right corner, we have a 3D printed model for the largest size bearing and the smallest size bearing in the vise to show what the project would look like inside that box if this vise was created. Thank you for looking at this presentation for this video, and I hope that this project looks the way that you would hope it would. Thank you.